One day we're gonna live in Paris. I promise.
Okay, so now let's look at a little something different. Okay, I just want to point out some trends that we see when looking at graphs. So let's say we have our 1 over x graph, right? And again, this looks like this, okay, on the left side, and on the right side it looks like this. Okay, so we see how at this vertical intercept, at x equals 0, we have our graph going in different directions, right? Because this one's going to negative infinity on the left, but on the right-hand side of 0, we're going up to positive infinity. So we have different behavior on either side, right? At our vertical asymptote, right? And we have an odd degree in the denominator, meaning x to the 1, and 1 is an odd power, right? So odd power, or we could even say degree, because it's the highest degree, in the denominator. And that was supposed to be degree. Let me write that again. Degree in denominator. Okay, so on the other hand, let's look at 1 over x squared. What does that one look like? So we have our graph here, and this one actually looks like kind of the same, or kind of similar anyways, but this time the left side is flipped up to the top, right? And we have our vertical asymptote at the same place, okay? But this time we see that we have like behavior, or the same behavior, meaning that our function is approaching the same kind of value, same type, meaning positive infinity in this case, right? So we see that we have same, or like behavior at the asymptote, at the vertical asymptote. And that's because we have a positive, we have an even power, or we can call it a degree, because it's the highest degree, or highest power, in the denominator, okay? So that's just kind of a trend. When you have an even power, or degree, degree is the more proper term, because that means when your highest power in the denominator is even, then we have like behavior at your vertical asymptotes. And when it's odd, then you have opposite behavior going on. Okay? Okay, so this example is going to be super thorough, I think, in our understanding of, it's really going to test how well we know how to calculate vertical and horizontal asymptotes and intercepts. Okay? So, as for vertical asymptotes, let's find those first, okay? So vertical asymptotes are when the bottom is equal to, or the denominator is equal to 0, but the top is not. So that would be when x is equal to negative 1, and when x is equal to 2, okay? So here, though, remember on the previous slide I was explaining about even powers, odd powers, stuff like that in the denominator. So if we look at the grouping for x equals negative 1, so this guy right here, we see a power of 2. Right? So at this vertical asymptote of negative 1, we should see like behavior from our graph. Okay, so that it's either going to on both sides of this vertical asymptote, the graph is either approaching negative infinity, both sides, or both sides are approaching positive infinity. Okay, and we'll see as the problem goes along. And as for x equals 2, then we see that's a power of 1, right? So we should have opposite behavior here. Okay, so I'll say like behavior and unlike behavior. Alrighty, what else can we deduce from this function here? So we can see that, well, how about the horizontal asymptote? So let's compare the degrees on the top versus the bottom. So on the top we have some kind of x squared, and on the bottom we have, let's add up the power. So we have x squared times x to the 1, so x to the third. So this behaves like a 1 over x. And that means that our horizontal asymptote is going to be y is equal to 0. Okay, so we got those out of the way. Now let's just find our vertical and horizontal intercepts just for the heck of it, because we're just going to pull out all the stops to sketch this graph. Okay, so as for vertical intercept, that is when x is equal to 0. Okay, so if we plug that in, we get f of 0 is equal to 2 times negative 3 over 1 times a negative 2. So the negatives cancel out and we just get a positive 3. Okay, so our vertical intercept is going to be the point 0, 3. You know, the more information you have when you go into graphing, the more accurate your graph is going to be. Okay, so lastly, let's just find the horizontal intercepts. So we're just going to set the top equal to 0. So x plus 2 times x minus 3 is equal to 0. So we just get x equals negative 2 or x equals 3. So another couple points that we just found pretty quickly was negative 2 comma 0 and 3 comma 0. Okay? Alrighty, so now let's take all of this information and we're just going to translate it and stick it on a graph on the next slide. Okay, so we have vertical asymptote. I'll just list all the information we had from before. So x equals negative 1 and like behavior. X equals a positive 2 and opposite behavior, so unlike behavior. Okay, we have horizontal asymptote of y equals 0, a vertical intercept of 0, 3, positive 3, and horizontal intercepts of negative 2, 0, and 3, 0. Okay, so now let's get to graphing. So let's say we have something like this. Okay, so here's our x and here's our y. And let's go, I don't know, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and 1, 2, 3. I'll do 4 on all sides. Okay, so let's just graph the points for now. Okay, so we have vertical intercept of 0, 3. So right here. Okay, we have horizontal intercepts of negative 2, 0, and 3, 0. So right there and right there. And now let's fill in our, so we completed the graphing our intercepts, and now let's make use of our asymptotes, right? So we have this horizontal asymptote on the x-axis, which is the same thing as saying y equals 0. So I'm just going to put a dashed line here. Okay, so we have a horizontal asymptote here. All right, we have vertical asymptotes at x equals negative 1. So let me attempt to draw a straight dotted line here. So here's x equals negative 1, and at x equals positive 2, okay? So right down in here. Okay, so now we have kind of like a grid or guidance as to how we're supposed to graph. Okay, and we also know that at x equals negative 1, we're supposed to have like behavior, right? They're either both going up or both going down on either side of that vertical asymptote. And at x equals 2, we have unlike behavior. Okay? So the guiding thing here is to start in the middle, kind of, with this point here, all right? Because we see, well, we can't really have it pointing down because that means it would cross the asymptotes here. And we're not really allowed to do that. If a graph, in general, kind of, asymptotes are known to, well, it's funny because I learned this, when I was learning this, my teacher slash professor, their saying was don't touch the asymptotes. Right? Because in general, like I was saying, functions approach or graphs approach asymptotes, but they don't touch them. Okay? So in all cases, in most cases, and at all costs, they kind of just tend away from asymptotes. Okay? So in saying that, I just mean to say that, like, so our graph in the middle, this little segment here, it's more inclined to travel upwards and away from this horizontal asymptote as opposed to going toward it and trying to cross it, because they usually don't do that. Okay? So having done this, having graphed this middle segment, then we know, okay, so this is the vertical asymptote of x equals negative 1, and our behavior on either side of the asymptote are supposed to be like or similar, right? So that means that also we have to have our graph going upward on this side, so that means we have something going on like this, okay? And then we have it going toward our horizontal asymptote. So everything kind of tends toward the asymptotes, but doesn't really touch them, okay? And on the right side over here for this 0, let's see what's going on there. So at x equals positive 2 for this vertical asymptote, we should have unlike behavior. So if on the left side we're going up to positive infinity, on the right side we should be going in the opposite direction. aka to negative infinity, okay? And then this probably levels out like that and goes toward our horizontal asymptote in the long run, okay? So when we have some kind of, any kind of rational function, which has the general form of this, when we factor it out, let's say, let me write it out first and then I'll explain what's going on, okay? So when we have something like this, and again, this just denotes the general form of a rational function. Okay, and then so that's the numerator, and then the denominator is going to look something like x minus, I'll just use different letters, right? So x minus v2, and then q2, okay, going along. And then the last one is going to be x minus v and m, and then qm. Okay, so again, like I said, this is just the general form for a rational function, okay? And what goes on is that on the top, all of our x1, our x2, and all of these ones with x with subscripts, so this one here, this one, and this one, these give us our horizontal intercepts, okay? Because all of these would make the numerator equal 0, which means our function equals 0, okay? And then so at each of these, the powers, P1, which corresponds to x1, P2, which corresponds to x2. See the powers there, right? So the powers give us the multiplicities of those roots, right? So that's how we would find, and we've seen this before. If it's a 1, then you have like some kind of linear crossing of our horizontal axis. If it's a 2, you have some kind of like parabolic thing going on with a U. If it's 3, then you have like an S shape or something like that, okay? So the P powers, they determine what goes on near your roots, okay? And then now let's look at the bottom. So then we have V1, V2, all of these guys to VM, they give you your vertical asymptotes, okay? So when x is equal to any of these, so x equals V1, for example, that gives you an equation for a vertical asymptote of your function, okay? And then if we look at the powers on those, if we look at Q1, Q2, all the way through Qm, those will tell us whether they're even or odd. If it's even, then we have like behavior on either side of your asymptote. So like behavior, meaning they both go up on either side, or they both go down, okay? Or odd powers tell you that we have unlike behavior. So they're just going in opposite directions. So on one side of your asymptote, you'll be going up, and the other side you'll go down, or vice versa. You'll go down on one side and up on the other, okay? Alrighty, so that concludes the concepts video on rational functions. I hope that helps, and I'll talk to you in the practice problems video if you watch.